So ladies and gentlemen, once again welcome to our physics class, and in this class we are going to do our part 2 of projectile motion. I'm pretty sure we can all remember our part 1 on projectile motion. So in case you missed part 1 of our lecture, please make sure that you go to our YouTube channel and you'll be able to watch that for registered members only, because the classes are only accessible for registered members. Yeah, so like I've already said, we'll look at projectile motion, and in lecture 2, like always, I normally focus on calculations, and this class will be made very short because we have a mathematics test at 21 hours. So we have a mathematics test at 21 hours. So once this class is done, make sure that you are available in the group for registered members. So can just one person confirm if I'm audible enough and if you can see the screen with the animation on it?
You are audible, sir.
All right, thank you. So I'll start with example 1, and in example 1 mostly I'll focus on horizontal launched projectile, but these are not the only examples I shall use. I am also going to revise with you where I'll use Wunza tutorial sheets and also Wunza past papers, so that the workload on you can be reduced. So let's quickly look at the first example. The first example is saying a plane traveling with a horizontal velocity of 100 meters per second is 500 meters above the ground. Okay, so let me try to showcase this work in terms. So let's assume this is our plane. Don't mind, I'm sure planes have tires. Yeah. So this is our plane. So if you look at this plane, this plane is normally traveling at the ground. So let's say this is our ground. Okay, so this is our ground. So this is the plane. Okay, so this is the plane. So this plane is traveling at 500 meters above the ground. So that simply means that the distance from below up to where the plane is 500 meters. So I'm just trying to showcase it in terms of diagram or how you can view this question before we go into details. So this is 500 meters. Then above the ground, so remember this is just the ground, and then at some point the pilot drops a bomb on a target below. So remember, the plane is always being flied by a pilot. So let's say we have a pilot there. I'm sure this pilot has to be a female. Okay, yeah, let's promote ladies, and this is the highest. So this pilot had to drop the bomb on a target below, and the question is, how long is the bomb in the air? So how long, the question of how long, when you hear the word how long, then they are asking about what? They are asking about time. Then B, how far away from the point above where it was dropped will it land? Okay, so this pilot had to drop a bomb. Okay, so there is a bomb that has been dropped. So let's say this is the bomb, and maybe the target is somewhere there. So maybe this is like a human being whom they want to kill, or maybe it's just a building which they want to destroy during the war. Yeah, though war is bad, but we are just trying to use physics. So this bomb which has been launched, we are being asked to find how long did it take for this bomb to reach from there to that particular target. So this is just the target which they want to destroy, or the person they want to kill. Okay, so the people in this movie, they normally have one eye. So how far away from the point above where it was dropped will it land? So normally they are looking for the horizontal length. So this is just the animation that, or the diagram on how you can try to view the given concepts in the question. So let's now get to the point and do the solving and see how you can go about. So the first thing that you need to take note of is, what do you have? So that's what we normally call data collection. So you need to ask yourself, what do I have? Okay, so can someone tell me, what do we have in this question? What do we have in this question? Okay, I can see a hand has
we have distance and speed.
Okay, we have distance and speed. Distance, speed, and distance. Do you think this is really what distance is this? What distance is this? Because remember, when a projectile is launched, let's say a projectile is launched from this particular point, when it is launched that side, okay, a projectile, it always has the horizontal distance and the vertical distance. So what do you think this distance is? Is it vertical or horizontal? Is it vertical or horizontal?
It's horizontal. Which one? The one that you've drawn?
Yeah, this one in the question. Is it vertical or horizontal?
It's
Horizontal.
horizontal.
It's what?
Horizontal.
Not really. So it is a vertical distance, guy. I'm right. Above the ground, you even saw the diagram. When they say above the ground, that means that it is up. It is up. Okay. So this is the vertical distance. Okay. Now, with this information in mind, let me now quickly collect data. But before I collect data, what other component or data have we been given in this question which has not been shown? Can someone try on this one? What information has not been given here? Let's try.
Acceleration due to
Exactly. Exactly. The acceleration due to gravity. The acceleration due to gravity. Remember that the vertical component of a projectile motion has an acceleration which acts on it, and this acceleration is the acceleration due to gravity. So let's quickly look at what we have. So this is what we have. So what we simply have now is that we have the velocity. Okay, here if you look at Vx, Vx, it is 100 meters per watt per second. 100 meters per second. Now This 100 meters per second, remember when a projectile is thrown in the air and it is going like that, what did we say about the velocity? What did we say about the velocity, which is in meters per second? What did we discuss about the velocity? Someone to give it a try. In the horizontal component, this component here, remember, I am sure I remember having a diagram which had arrows like that. It should be blue arrows. That's why I normally use different colors for us to remember. There were blue arrows, and then there were also red arrows which were going up, and the red arrows were normally in the what? The red arrows were showing the vertical component. So according to you, according to what we learned, when we talked about velocity, what did we discuss? Okay, I can see someone's hand is up. Hagai?
There is no acceleration in horizontal component. The
Yes.
speed is constant.
Okay, correct. So the velocity is normally constant in the horizontal component. Those people who missed the first class, such is what you missed. So the velocity is constant in the what? In the vertical component. So let me quickly look at how we can solve the time. Let me quickly look at how we can solve the time, because we are looking for the time, isn't it? We are looking for the what? For the time. So for the time, how we can easily work out the time, we can easily use the y component. We can easily use the what? The y component of this guy. So remember, we have a formula which is distance, should be distance is equal to, let me just quickly go there, this one here. So remember, there is something like vt plus half at squared. Okay, vt, the distance, so in this case, since the distance it is y, so the distance is equal to vt plus half at squared. So at in that equation, a has been replaced by g, and then this v is normally what? 0. So the v is normally 0 meters per second according to the information there. So when you put 0 there, that means that this whole thing will be 0. That's why in this formula we haven't included what? We haven't included this part. So this component, it is very helpful when you are trying to find what? When you are trying to find the time. So this is the formula that you are going to what? To use. So this is the formula that we are going to use. Now this y, it is the vertical distance. This y is the vertical distance. Remember, when a vector is launched, when anything is launched, when it is launched in that way, or it is launched in the other way, or it's launched in any direction, it has the vertical and the horizontal component. So in this case, what you need to understand is that the vertical component, the distance for the vertical component, it is the what? The 500 which we were given. Okay, so the 500 which we are given, this one here, the 500 which was given, this one here, guys, it is the one which is representing the what? The distance in the y component. And this formula you are seeing here, it should not run away from your mind. Even when it tries to run away from your mind, try to chase it until you hold it, or you catch it. This formula here. So y is equal to half gt is the one which will help us to have what? It's the one which will help us to find the what? The time. Okay, it's the one which will help us to find the time. So after you do that, you know the distance we are going down, isn't it? So the distance has been placed to be what? To be negative. So where there is y, which is the distance, we have put what? We have put a negative there. Now we have the other side. We know that g, which is the acceleration due to gravity, it is what? Negative 9.8. So you can cross multiply there. Once you cross multiply, you do everything, you are going to find that your answer will simply be 10 meters per 10.1 seconds. So that's the time in that case. Do you have any question before I move on, or I explain again? I don't know if we have any question. Yes, Florence.
So I wanted to ask, the formula that you're supposed to be using when finding time is the same one that you're supposed to keep?
No, it depends with the information you have been given. It depends with the information that you have been given. So look about projectile. The normal, okay, the normal formula according to Newton law, it is S, which is distance, is equal to Vt, okay, plus half At squared. So I'm going to give you this hint which act as a secret when you talk about projectile motion. So normally in projectile motion, this component here, okay, this component here, it goes with the what? The y component. Okay, the y component is the one which goes with this guy. Why? Because the velocity is what? Is 0. The y component, in most cases, the velocity is what? Is 0. That's why we normally use this part to represent the what? The y component. Then another secret which is there from this same formula, it is this one here. So this one normally goes with the what? The x component. This one here goes with the x component. Why does it go with the x component? Because this acceleration, there is no acceleration in the x component. There is no acceleration in the x component. I hope that is clear. And there is no velocity in the y component. It might be there in some questions, but in most cases you need to understand that. So if you look at the question here, you need to understand that the only component which is having everything is the y component, because we have the distance and we have the what? We have the distance and we have the what? The acceleration due to gravity. But if you look at the yx component, we don't have the distance and we don't have time, so we can't use the x component. Okay, I hope that is clear. Is that clear or no?
It's clear, sir. Thank you.
All right, so make sure that you analyze. At this stage we have reached in physics, you need to analyze each and every question. Okay, so projectile motion has so many questions, and I'll make sure that I tackle as much type as I can. So this is how easily you can do it. You just say y is equal to half, okay, where there is Frederick, wait a minute, Where there is a, you're going to put g, then you put t squared, then y you have is 500 there, 500, and then is equal to half, is equal to half, and then half times where there is g, you're going to put 9.8, and then times you're going to put t squared. From there, you're going to move 2 times 500, 2 times 500, it's going to be 1000, and then there you have 9.8 t squared, and then there you can divide throughout by 9.8. There you're going to have divide by 9.8, this one and that one goes. T squared is equal to 102.902.04, and then there you're going to introduce a square root, that one, and t will simply be equal to 10.1 second. So for those in case the formula has confused you a bit, that's how we have moved. So in case you're having challenges with network, don't worry, still be around, and don't worry, the class is being recorded and it will be sent, so make sure that you go through. So this is how easily you can do the solving. Do we have anyone with a question? Anyone with a question before I move on? Anyone with a question? Yes, Frederick, what's your question?
So my question is on negative 500.
Yes.
Why has it become a negative?
Because
and another question is on this 1000 that I'm seeing on the other side.
Which one?
How did you get it? The 1000, how did you get it?
I did 2 times 500, it is 1000. 2 times 500, it is 1000. Then the distance is negative because we are going down. We are going down, and it is in relation with the gravity which has been given. So if you take up to be positive, then going down has to be negative. If you take up to be negative and down to be positive, then both have to be positive. Is that okay?
Yes, it is okay. And the question is, how did you? Okay, I'll ask that question later.
All right. So let me quickly move on and look at this. Now look here, the puzzle has been solved. How has it been solved? The thing is that we now have what? We now have time. So when time has been given, which is now 10.1, which is now 10.1 seconds, okay? Since time we now have, then it's very easy for us to use this formula, this side of the x component, to find what? To find how far away, okay? So how far away, it is more like they are telling you a distance, the horizontal distance, okay? How far away, then they are talking about the what? The horizontal distance. This statement here, how far away, they're just telling you the horizontal distance. Now since we have the time, since we now have the time and we have the velocity, it's very easy for us to find the horizontal distance. Let me repeat that. Since we have time, we now have time, one. Since we now have time, and we now also have the velocity which doesn't change. The velocity which doesn't change, which has been kept constant throughout, the 100 meters per second. Since we have that data or that information, it's very easy for us to find the what? The x component which is the horizontal distance. So how can we find that? We're just going to use the formula which I've given up there, which is that one there. Simple. You see? Just simple. So if you just understand this thing, you are able to understand everything. But remember, this projectile has not been launched on what? On an angle. So the only spice which will come in there, it is when it is launched at an angle. But since it is not launched at an angle, you need to understand that you can just move freely. So in this case, you use the formula, which is that particular formula, and then when you plug in there, the answer is just simply 1010 meters. So this is the answer. Do we have people with a question or not with a question? Please feel free to ask so that we can move at the same point. Anyone with a question? So this is the x component. This is the x component. In other words, like we discussed, this is the what? The horizontal component. This is the horizontal component. So that's how easily you can analyze these questions. So let's move on and look at the other question. I was expecting the class to be short, but I want to go a bit in detail. So example 2. The question is, a place kicker kicks a ball with a velocity of 20 meters per second. Understand the concept there. Okay? Understand the concept. Before you even do anything, first visualize. That's why our lecture 1 had animations. Okay? So a person, a place kicker, I don't care if it's a person or whatever, kicks a ball with a velocity of that. Now look, if this is a person, okay, this is a person, and this person kicks the ball, I'm sure this person needs to have boots for football, so is also wearing boots for football, and this is a ball. Okay, so this is the ball. That's a ball here. So this is the ball. So this person kicks a ball at a certain angle. This person kicks a ball at a certain what angle. I'm sure he needs to also have some dreads. You need to have some dreads here. This person kicks the ball at an angle in that way. Okay, like that. Now, this person, as he kicks the ball, this ball is not just being kicked anyhow. It has been kicked at an angle. So with that information given, that simply means that you have the what? You have the x component and the y component. You have the x component and the y component. Remember, we have been given what? The angle. So the angle which we have been given here is 53 degrees. So if you look at this question, just from the first statement, I'm able to analyze such that I've been told that this ball is moving at a velocity of 20 meters per watt per second. What do you understand by this? What you need to understand now here is that you need to go and visit vectors. You need to now go and visit vectors. So when you visit vectors, this is what you are going to see. You're going to see that this is the resultant. This is the what? The resultant. Okay? And this is the what? Is the x a y component, and then this one is the what? Is the x component. Then once you understand such, you are now going to remember the formula we were using. We are now going to remember the formula you were using. So the formula we were using for the x component, can someone remember it? Anyone who can remember it? The x component, what was the formula? Okay, I can see Frederick hand is up. What's the formula, Frederick?
Vx equals to vector v times cos theta.
Yeah. And the y component, what were we finding?
Vy equals v times sin theta.
Exactly. Guys, even if you fail, even if you fail, then you have just chosen to fail. These things are easy. Look how I've analyzed. I've borrowed just information from vectors and brought it up. Now, observe what I'll do with that information. What I'll do with this information, I'll do this. I'll go back and visit my formula for what? For my formula for projectile motion. So my formula for projectile motion is that S is equal to Vt, okay, Vt plus half At squared. This is the basic formula that everyone who knows, of which I know that this is giving me my what? My x component. So my x component in this formula, because there is an angle there, I am going to say x is equal to where there was v, I'm going to put what? I'm going to put where there was vx, I'm going to put v cos theta times time. Have you seen how the formula has changed? It has changed because it is an angle. It has changed because it is an angle. Because this part here, is representing what? Vx. That part is representing Vx. That's how it has changed. Then, another thing that you need to understand is the y component. The y component, I'll normally use that guy there. And the y component shall remain the way it is. The y component shall remain the way it is. But in case I'm asked to find the velocity, I might utilize another formula, but it has to be at a particular angle. So I'm sure this information has been explained. I don't know if there is any question before I even go to the solving. I know what I'm doing and I know what I have to do, because basically I know they will ask me time. Since they haven't given me time, they might ask me velocity. Since they haven't told me velocity, they might ask me to find the distances. Remember, I can see the distances here. Maybe they'll give me the distance. So it's just knowing what to do before I even do it. So with this information, let me move on. I don't know if there is any question. Please, if there is any question, feel free to ask so that I can move on. Feel free to ask so that we move on at the same pace. Okay, no question. All right, let me quickly erase my friend who was kicking the ball, and this ball was launched at an angle which leads to the velocity having the components. And then we looked at those guys, how they have changed from how they are to this way. So let's quickly look at the question. 1. How long is the ball in the air? Like I said, they will automatically ask me about time. How long was the ball in the air? Then, how far away does it land? How far away does it land? When it was kicked by this guy, when it was kicked from this guy, it had to undergo a what? A trajectory. So now they are asking us how far away. This is how far away. Far away. Away. Okay. Now, then the next question is how high does it travel? Have you understood there? How far away it is the horizontal. How high is the what? Is the vertical. This is the how high. For the sake of my friends who never learned English somewhere. So how far away is the horizontal? How high is the vertical? Okay. Now, there is the hidden information they haven't given us. And that hidden information is simply the what? The 9.8 meters per second squared. That's the only hidden information these questions they normally don't show. So after you understand this, you'll be able to gather the information. What I'm drawing is what we call a free body diagram. A free body diagram doesn't have a person, it doesn't have a ball, but it just shows the motion which a certain object had to undergo. Now, this vector here is the resultant. Now, that resultant in blue has the what? Has the x component and the y component. So the x component is in red and the y component is also in red. The velocity was given to be 20 meters per second. Now, what am I trying to do? Before I even do any part of the question, I need to know the x component and the y component. So I'll utilize the resultant which has been given and the angle which is there. So in this case, I'll use those formulas. The ones I've been explaining, the ones I was explaining, the ones which our colleague Frederick helped us with the formulas. So I'll find the x component of this particular vector, and this is the x component. Easy. And remember, your calculator has to be in what? In degrees. So once I find my x component, I can also now find my y component. I've already explained the formulas. So to find the y component, I shall use this particular part here. So this part I've just used the y component, and that's how easily I have found the answer. So before I move on, ladies and gentlemen, do we have any single question from you guys? Is there any single question from you guys? Any question? Please, let's ask. Any question? Okay. Now, look. What I've done here has not solved the questions. What I've done here, I have not solved the questions. So my job now is to go and quickly analyze the questions which I've already done. Then now I can easily see what I can do with this information I have found. So let me quickly go to the question. That's the question. Now I'm finding how long is the ball in the air. How long is the ball in the in the air? So if you observe very well, which component are we going to use? That's what you need to ask yourself. Which component, which is having everything, are you going to use? Which component are you going to use? You don't have time. Remember, you don't have time. You don't have the distances, but all you have is velocity. So let's quickly now look at what you're going to have. What do you have? So what we know is that the velocity, the x component is 12.04, and then the y component is 15.97. Then remember the distance, which has been treated to be what? To be 0. So let's quickly look at how best we can solve this. So the best way is for us to use what? The y component. So we are going to use the y component by treating this y to be 0, by treating the y component to be what? To be 0. What do you understand for that particular part? What we understand is that we know that the initial velocity was what? The initial velocity was 0. Oh, was 0. Was 0? No, wasn't 0. It was this 15.97. So the initial velocity was 15.97, and the distance that was there, it was what? It was 0. So you're going to plug in there. Then this y will automatically be indicated as a what? As a 0. The y will be indicated by a 0. And then this 15.97 is going to occupy the initial. The 15.97 will occupy the what? The initial. So in this case now, the initial, we have it. So you're going to reach at this particular point, just like that. Now, after you do that, all you need is now just to work out. All you need is now just to do it, to work out by taking this other guy to the other side. I think this part I need to write it. So what you have is this. What you have is this. You have the initial distance to be 0. So you have y is equal to v0y plus half gt squared from that formula. Then you know that this guy is 0 and then is equal to this. We already have it. We solved it on the previous slide. So it is 15.97t minus, we are treating going up is negative, minus half 9.8 times 9.8 t squared. Then this 2 into that, it's going to be what? 4.9 t squared minus that 15.97 t, which is equal to what? To 0. So this one can go to the other side, or that one can go to the other side. Okay, so I can take this one to the other side, or I can take this one to the other side, because I know even if I take this one to the other side, it will be positive. If I take this one to the other side, like in that case, then it will be negative, but the negatives will still cancel out. So I'm going to have 4.9t squared is equal to 15.97 t. Now remember that t squared is 2 t's. There are 2 t's there. Okay, so if I divide throughout by tt, if I divide throughout by a t and by also a t, then 1 t and that t will go, and that t and that t will simply go. So what I'm now going to have is 4.9t is equal to 15.97. Then I divide throughout by 4.9. I divide throughout by what? 4.9. So when I do that, the 4.9s on the right left hand side, they are going to cancel. This one into that, it's simply going to give us 3.26 seconds. That's all. You're done. As simple as that. But me solving here, it looks simple. You now need to go through yourselves. So let's quickly move on. But before I move on, do you have any single question? Any single question, ladies and gentlemen? Any single question? Okay, it's like we don't have. The next part of the question is, how far away does it land? How far away does it land? So remember that now we have the time. Now we have the time. So what we need to understand is, now we have the time, which has now appeared there. I think we can all see the time, the one on my writing in yellow. So now we have the what? Now we have the time. How far away is what we are looking for. Now when the question is saying how far away, they're just asking you to look for the what? The x component distance, which is this particular guy. Now, this guy is having the initial velocity, which is that one. The initial velocity, which is that one. And remember, the x component doesn't have what? Doesn't have acceleration. The x component doesn't have acceleration. Remember that. The x component doesn't have what? The acceleration. Why doesn't it have the acceleration? The velocity is distance. When the velocity is distance, there can't be any acceleration. A body can be moving, but if the velocity is the same, then there is no acceleration. Acceleration only exists when the velocity is changing. So, since we know that there is no acceleration in the x component, we are still going to use our formula. But our formula, it is the one which has vx0. But remember, this has already been, the vx0 has already been what? Has already been solved. That's why we solved them before we did anything. So when we do that, ladies and gentlemen, it's a walkover. It's just the issue of replacing there, and you do what? You plug on your calculator. Simple. Nothing to worry about. As easy as that. That's how easy the question was. You just plug in. So where was the puzzle? Me, when I'm solving questions, when I'm trying to understand the topic, I will always try to find out where the puzzle was. So the puzzle was you knowing how to find the y component and the x component. The puzzle was hiding on a part. You have to see the y component and the x component. This is where the puzzle was hiding for this question. If you are able to work out this puzzle without any difficulties, then you are able to move as far as that. Let's move on and look at something else. Where I've reached here, do we have any questions here at this particular point? Do we have any questions? Let's be free to ask. At this point, do we have any question? Any question from anyone? Prosper, do you have a question? Prosper?
No, sir, it's clear.
Okay, it's clear. Nelson, do you have a question? Baba Nelson, bari kuchigayo.
No, sir, it's clear.
Okay. Benson, do you have any question?
It's loud and clear.
Okay, alright, let's move on. The next one is how high. Now, guys, how high has a tricky part. How high has a tricky part. This is where people make a bit of mistakes on how high. How high, like I have said, has a tricky part. What's the tricky part? Cut your time in half. How high has a tricky part. And what's the tricky part? Cut your time in half. Now, I'm going to give you an assignment. Go and find out, why are we cutting the time
in half. Go and find out. When finding how high, why are we cutting the time in half? And why, like just why are we cutting the time in half? Now, when we cut, we have the time there, which is still 3.26, like it was. Remember how high? We are playing with the maximum what? Maximum height. Not the maximum which came in your mind, but this is the maximum height. Okay. Let me draw. When the ball was kicked, it went like yeah, and then it reached there. The maximum height, it is at that particular point, and this is what we have been asked to do, to find what is the maximum height. Now, if we are looking for the maximum height, which formula are we going to use? And remember, there is an instruction: cut your time in half. Simple. That's the formula you're going to use. The same formula. That formula we talked about at first. It's the same formula we are using, but this formula, it is having two parts. It's having when it is launched at an angle and when it is launched without an angle. When it is launched without an angle, go and check question 1. But when it is launched at an angle, then question 2 will help you. Now, when you use this formula, one thing you need to understand is that now we have the initial velocity. Which we derived in the first place. So once we have this formula, all our work has been simplified. But remember to cut your time into half. In short, divide the time by 2. Before you break it in, divide the time by 2. Don't just quickly, the formula has time, then you're like, you even put 3.26 seconds, I'm done. No, divide the time by 2 before you do anything when we are talking about the maximum height. When you plug in on your calculator, that's the maximum height. When you plug in on your calculator, that's how easily you can find the maximum height. Simple. So, ladies and gentlemen, this is what I think I had for you guys. So if there is any question, feel free to ask, so that I'll be able to respond. And in case you are shy, you can still WhatsApp me on those lines.